Welcome to The Explainer, where we break down complex topics into simple, powerful tools that you can actually use.
And today, we're diving into another one of those incredible single-step secrets from Vedic mathematics.
All right, so here's the game plan. We're going to start with what you already know, then push it in a new direction. We'll tackle a few practice problems, get into the really tricky mixed case, and finally lock in the whole technique. Sound good? Let's get started. So you've already gotten really good at multiplying numbers that are just below a base, right? Things like 98 times 97 using that neat cross subtraction trick. Well, the best part? The exact same logic works when the numbers are above the base. It's awesome.
And check out the beautiful symmetry here. When the numbers were below the base, we subtracted. So it just makes sense that when they're above the base, you guessed it, we're gonna add. It's the same core idea, just flipped on its head.
Okay, so let's break this down. It's really just two super simple steps. For the first part of the answer, you just cross-add. Take 103 and add that 4. Boom, you get 107. For the second part, you just multiply the surpluses. So 3 times 4 is 12. Stick them together and you've got your answer, 10712. See? Super easy.
All right, you've seen the theory, now let's actually get our hands dirty. We're going to run through a few of these together.
Okay, first one up. Let's try 102 times 104. So, first question, what are our surpluses?
That's it. The surpluses are plus 2 and plus 4. So you take 102, cross-add the 4, and you get 106 for the left side. Then you multiply the surpluses, 2 times 4, which is 8. But we write it as 08, right? And there's the answer, 10608. Perfect.
All right, let's try one that's a little bit trickier. What happens if the surpluses are a bit bigger? Here we've got plus 12 and plus 5. Let's see if the process still works.
And look at that. The process is exactly the same. You cross-add 112 plus 5. That gives us 117. Then you multiply the surpluses, 12 times 5, which is 60. Now our base is 100, so we have 2 spots for our digits on the right. 60 fits in there perfectly. So the answer is just 11760. No problem.
Okay, let's scale it up. What if we have a bigger base? This time, the base is 1,000, which means that right-hand side needs to have 3 digits. Right, so our surpluses are plus 3 and plus 6. We cross-add. 1,003 plus 6 gets us 1,009. Easy enough. Now, for the right side, 3 times 6 is 18. But, and this is the important part, our base is 1,000, so we need 3 digits. So we can't just write 18, we have to write 018. Put it all together, 100918. Done.
Okay, so you've totally got the hang of numbers below the base, and now you've mastered numbers above the base. But what happens when we mix them? One above, one below. This is where it gets really interesting.
So how would you even start to tackle something like 103 times 98? You have one number above the base and one below. Let's walk through it together. Okay, we've got a surplus of plus 3 and a deficiency of minus 2. Now the first part feels familiar, right? You can either do 103 minus 2 or 98 plus 3. Either way, you get 101. But look what happens when we multiply for the right-hand side. Positive 3 times negative 2, that gives us a negative 6. What on earth do we do with a negative number in our answer?
So here's the secret sauce. Obviously, we can't just stick up minus 6 on the end of our number. That doesn't make any sense. In Vedic math, this situation is shown with a little bar over the number, and it's called a vinculum. Basically, you can think of this as the architect's plan. It's not the final building, it's just the blueprint. It's a signal that there's one more step.
So if that was the architect's plan, now it's time for the builder to come in and finish the job. All we have to do is take that left-hand side, the 101, add the zeros from our base, so that becomes 10100, and then just subtract that 6. And just like that, the builder's work is done. 10,100 minus 6 gives us the real final answer, 10,094. It's an extra step, but it's a simple one.
Okay, that final step is absolutely crucial. So let's lock it in by practicing with a few more examples.
All right, let's tackle a big one. This is straight from the source texts. The base is 1,000. We've got a surplus of positive 112 and a deficiency of negative 5. Let's just follow the exact same steps. Okay, step 1, the left side. 111, 12 minus 5. That gives us 1107. Easy. Step 2, the right side. We multiply plus 1112 by minus 5, and that gives us negative 560.
So now we have our architect's plan, 1107 and negative 560. Time for the builder. We take 1107, add the 3 zeros from our base, and then subtract 560. And that gives us our final answer, 1,106,440.
Okay, let's just pause for a second and summarize the absolute key points here, just to make sure this new skill really sticks. So, let's just really hammer this home. For the surplus cases, the ones where both numbers are above the base, it's simple. You cross-add and you're done. But for the mixed cases, you have to remember that the right-hand side is going to be negative, and that means there's a final step. You've got to subtract that number from the left-hand side after you've added the zeros from the base. That's the whole game.
And please, remember this architect versus builder idea. It's so helpful. The architect sets up the plan, giving you that intermediate answer with the negative part, but you can't stop there. The builder has to come in and do the final calculation to get the actual, real answer. Stopping at the architect's plan is hands down the most common mistake people make, but now you know exactly how to avoid it.
So, you've now completely mastered multiplication for numbers that are near a base. But it probably gets you thinking, how could you adapt this same logic for numbers that are way far away from a convenient base, like 47 times 49? Well, that's a question for another time. But it just goes to show you that these simple rules are the building blocks for an entire system of faster math. Keep practicing, and you'll be amazed at what you can do.